Okay, so this is going to be my first recording, and it's probably the 9th take of the first recording. I just started this a little earlier, and I was still running Gnome on my Ubuntu machine. And the moment I started recording, my memory usage jumped up to 75%. Most of that, like 50% of my 16 gig was taken over by Gnome. By the Gnome shell. I don't know what was going on. The CPU also went through the roof with the screen recorder taking about 40% and then Gnome another 40%. So obviously I couldn't have done screen recording with that kind of a performance impact by the screen recording. But now everything seems to be in order. So SimpleScreenRecorder takes about 250%, so about 2.5 cores. That's 1/3 of the CPU in total. It's not very little, but it's survivable, especially considering that it's a 4K monitor. So yeah, I'm just gonna walk through my setup here and help anyone who wants to do their own screen recording on a Linux machine to do screencasts for software development or whatever you do. So what I have is Jack, which is actually, let me open another Jack Audio, which is a Linux setup or a tool where you can kind of connect different devices, and so it's I think it's an audio server. I'm using that to allow both me to actually, like, I could also connect my Bluetooth headphones right now and listen to my own audio so that I could make sure that the audio quality is good. And I can select different microphones. So right now what I'm using is up on top of my monitor there is a, hold on, let me show you. This one, which is, I'm not going to touch it, otherwise there's going to be a lot of noise. A Zoom H1, which are these. And they're like $50, I think. This one. And you can connect that to either the normal line-in of your computer or even as a USB microphone. And then Jack can also use that. I'm using line-in right now because of my mini USB cable is broken. But later on I'm going to change that and use it as a USB microphone. So that's my microphone. Then for the camera, this one, I'm actually using my smartphone. So I have my smartphone on a tripod and then just put it next to the monitor. And I installed an IP camera app. I'm not exactly sure what it's called. I think if you go on the Play Store and you look for IP camera, you're going to find a bunch of apps. I personally took this one. No, not this one. I clicked here and then I saw another one which is similar. I'll write that in the description once I know. Anyways, it's a very simple app that just takes the camera stream of my smartphone and exposes it to the network. So that would be this one, and it's not going to be able to do this as long as this one's connected. So it only takes one connection. And I made that turned that into a little application that can run on its own. So that is this command with a natifier. You can get natifier on npm, which is the node package manager, and it basically allows you to create a native app from a web app. So I have also a Trello native app, and I have a Gantt chart native app, which are my organization tools. And so you can use that to turn the website I showed you earlier into a little app. And so this one I can then set to always float atop all the windows. So this one's always going to be on top. And yeah, I ran this command, which is basically how do I zoom in? Oh, here we go. Wait. Yeah, it's not yet set to always on top, as you can see. So that's this command, natifier, and then I gave it an icon so that it has a little icon here and a name, and I injected some CSS because I want my phone to be in a certain orientation, and if the stream only streams in one direction, so it'll be upside down. So I injected something that takes the image of the website and flips it. And then I set it to the width and the height, which is the width and the height of the recording, and the URL. So it's kind of neat. Yeah, then I use to kind of organize my windows. This one is not really regarding the recording. Oh yeah, wait, the recording is SimpleScreenRecorder. Just this one. And let's go on the website itself. And it basically just allows you to record everything, as you can see here. It's a preview. It also gives me audio preview and everything. And I think actually if I turn off the preview, the CPU should reduce a little bit in load. We'll see this here. So this is my average CPU load. It doesn't really make too much of a difference. And yeah, it's for me on Ubuntu, it's just SimpleScreenRecorder installed via apt-get. And that's it. Then I also have this Gnome Alsa mixer, but that's just for I don't even know. I think I installed it because I couldn't listen to my microphone, or I couldn't listen to my microphone, so I was trying to kind of get a loop back and kind of connect the output, like the capture, into my output so I can listen to myself. That didn't really work with this though, so yeah, otherwise I think that should be most of the things. The moment I'm going to start coding, I'm going to use Tmux, and then use Vim for the coding. And what I'm going to do is basically walk through all my developments of my master thesis topic, which is competitive brokers in a electricity or an energy trading market environment. So my broker has to create tariffs for customers. It has to generate attractive tariffs that customers will actually subscribe with. Then it has to trade electricity in the wholesale market, and it has to make sure that the portfolio is balanced. And then it also has to, or doesn't have to, but it's definitely better if it does, act in the balancing market, which is basically you trade electricity 24 hours ahead of time, and then on the actual spot when the electricity demand is realized by your customers, it might be more or less than what you expected, and there needs to be a balancing happening, and that's very, very close to real market situations or real electricity network situations. And so you can also trade there, and you can kind of offer your overproduction to the balancing agency. So yeah, these are the things that the agent is supposed to do, and it's supposed to do that automatically for a couple of thousand of customers. And so I'm going to use different forms of machine learning. So for the learning of the hold on. No, I don't have it written anymore. Anyways, for the first part, so for the learning of the I can cut this out. True. Never be nervous in front of. So for the trading in the tariffs environment, the agent has to estimate the quality of a tariff. So, I mean, I want to push tariffs out into the market. They have to be competitive, and they have to make profit, right? So the first task is to make competitive tariffs, and that is a very supervised kind of problem because, well, there have been previous simulations of this competition that I'm writing the broker for a couple of years. So there's, I don't know, I think I have like 300 or 400 gigabytes of previous logging data that I can sift through and kind of label tariffs regarding their attractiveness in relation to the environment they're in. So, I mean, that's very logical. Every product that you look at is only as attractive as it is in relation to the environment where it's placed in. So if the competition is very bad, then the product obviously is very good, even though it's not actual that special. But if the competition is very fierce, then yeah, so you get the idea. The input's going to be features from the market, so that will be average price per kilowatt hour, how much do customers get charged for kilowatt hours during the night, so like there's per hour throughout the week kind of labels, average and the variance of the market, etc., etc., and then all these values also of the tariff in question. And then at the output, the network has to kind of guess the quality of this tariff in respect to the environment that it's in. Now you can use the historical data and kind of see how many customers are subscribed to this tariff as a proxy to how good is this tariff. Because if it's a simulation, there is some fudge, like the rationality of the customers is kind of fudged, so they're not perfectly rational, but you know, in the statistically speaking, they are. On average, they will do the right thing, and so with a little bit of noise, there's a very good label regarding to the quality of the tariff. And so the first step is for my agent to learn what is a good tariff, and then the second step is generating good tariffs, which could be a so I would have a generating network that would generate tariffs, and then the second network that would evaluate those tariffs, and the first one would learn from the second one, which is already very good at estimating the quality, until the second one is also capable of generating very good tariffs. So the input of the second one would be the environment, and then it's supposed to generate a competitive tariff. Now, a competitive tariff doesn't mean that you make profit off of that. There has been a couple of examples where brokers have just gotten all the customers but made tons of losses because they just gave out very negative or bad, very cheap tariffs. So one problem there is obviously to select from those tariffs the ones that actually make profit. And I'm still going to have to come up with a solution to that. Then afterwards, the second environment is the wholesale trading. That one is kind of, yeah, it could either be a MDP, where each of the 24 hours is a is a state, and the final state is the one where the electricity is being used, so demand meets supply, and obviously the reward is the amount of cost that the broker has. So the less cost it has, or the more profit it has, the better. So that environment should also be interesting. An alternative to boost that, and I'm thinking about that at the moment, I think I could boost that with also doing some supervised learning in the way that I could watch how other brokers traded and how much profit or loss they made. So, showing how to trade to make less, to cause less costs. I still gotta think about that. Basically, though, the input is the estimate of how much. I forgot the second part. In between the first one, generating tariffs, and the last one, which is wholesale, there's going to be the estimate how much my customers are going to use, how much electricity they're going to use. You generate tariffs, and then you're going to have a bunch of customers, and so you got to estimate how much are those customers going to need in 24 hours or in 5 days. How many kilowatt hours are they going to use? And the input's going to be time of day, weather, different kind of factors. And of course, how many customers of what type do I have? And then the output is how many kilowatt hours do I need? And so then that number gets fed into the wholesale trader as a good estimate of how much electricity you're going to use. And the more you need, the more you need to buy, obviously. I could also feed in there not only an absolute guess, but also kind of a range or maybe a distribution that might be a little more precise, or it's a better decision base. It's very similar to what you learn in business classes regarding risk management. How much will you probably have to purchase, and then if you decide later, you get more definite information. The variance is going to get less wide if you just have to forecast the electricity needs for people in 1 hour versus 24 hours. But of course, electricity gets more and more expensive the more you reach, or the closer you step to this moment of now you're going to have to, like, the closer you get to T-0 kind of. And then the balancing market in itself is the most expensive. So these are the problems that I'm going to work on. It's going to be supervised learning, it's going to be reinforcement learning, it's going to be some, it might be, I'm not sure yet if I can use that, the one where like two networks fight against each other. Or not fight, but try to discriminate. I forgot what it's called, but I might have to do some of this. And I'll write all of that in Python. I'm getting my data through a Java application, so I wrote an adapter that gives me those into XML in Python, because the application was written in a way that only Java clients could join. So I wrote an adapter in Java that then translates it into a gRPC socket and sends the XML out that way. It's not perfect, but it gives me the data. And I didn't want to do unmarshalling of the XML, turn it into Java objects, and then turn it into gRPC binaries, and then send it down to the Python. So I'm just taking the XML that is used to communicate between the two Java instances, and I'm just going to throw that into a gRPC message and send it down the wire. I might also have to do some Kubernetes, I'm not exactly sure how you say that, because there's going to be quite a little bit of performance needed, I think. I'm not sure. This is my first time that I'm going into all of these kinds of fields. So I might have to do some Kubernetes to get some more power. And I'm going to run that in the cloud, so in the Google Cloud. So yeah, these are some of the things I'm going to touch on. I'm going to do most of my editing in either PyCharm or Vim. I'm kind of in the process of switching from these heavyweight IDEs to something more lightweight like Vim, because I started to see the benefit of the ability to do a whole bunch of things just with the keyboard. I mean, I have some fun screencast or Twitter posts where I don't know. There's just cool things you can do. So you can have variables. Actually, I'm just gonna maybe I have. Let's see. So yeah, I think it was just a kind of a screen recording of me playing around a little bit in Vim, and I'm very terrible at doing stuff in Vim and also talking at the same time. So I might also just record myself and then cut and talk later. I'll still have to think about how I do that exactly. But yeah, you can just, I mean, just the fact that you can do like these visual block edits in Vim is already a huge bonus. Then easy align is also great, so you can easily align a lot of things and get these like blocks of assignments. And removing things with the regex is also very, very neat. I think I was just generating a bunch of functions, methods for this Python class, and what I did earlier was I copied all the method declarations of the Java class into Python, and then instead of having to rewrite or just like manually type them away, I deleted the public keywords and then also the return values or the return types, kind of aligned the whole thing, then put a def in front of it and a path, so that I had all the stubs for the methods that I had to implement. Helped me a lot. And then so yeah, question is broker adapter. Okay. I gotta go to the Python broker, and then in here I want to do some Python. I hear my CPU doing stuff. Yeah. The question is just what's going on. I still gotta figure this out. I have this syntactic, and it's also, I mean, it's great in a way that it gives me feedback, but it often opens a bunch of these location lists, which are very annoying. When I reopen Vim, it generates all these location lists, and it creates more and more and more. Also, sometimes some of the buffers get opened multiple times, which is kind of annoying. So I'm still gonna learn this. But generally, I'm quite happy with Vim for now. Might change. And I have a few plugins installed, but I don't think it's too many. I'm slowly learning through using one after the other, kind of doing repetitive usage, and then wait until the fingers kind of get it. I mean, definitely Control P is an absolute must. Then these alignment tools that I talked about earlier. which is easy align. Definitely gotta get that. You complete me, not even discussable. It's a base tool for anything. I, for example, also use Vim to write my thesis, and I also have some things set up that automatically regenerates my sessions for different folders. So that's what this message was just about. Yeah, then I think I gotta look this up, which is this one nerd tree. Sometimes it's just too large, like when I open it for the first time, it's not in a nice and small form factor like this, but it takes half of the screen size. So I gotta check that, see what's up with this. Yeah, what else do I have? Snippets. Snippets are obviously nice, so you don't have to type everything again. Especially helpful in my LaTeX files. And surround, I still gotta learn. It's basically allows you to surround things with different kind of characters. So if you want to have a string and then you want to surround it instead of single quotes with double quotes, you can do that with this. This is just a color scheme, and syntactic obviously gives these kind of location lists where you get errors reported, and actually okay, interesting fact, invalid syntax right now. I gotta go into my virtual environment, and then when I open it, things should work out better. But as you can see now, I have these environment tariff. Tariff is open twice. And then this is just from previously, this Wundel, I don't know. I mean, I still gotta learn with Vim, but overall, can't complain. Okay. Yeah. That's really all I gotta say. So yeah, this is really all I'm gonna say. Next video is gonna come at some point. It's going to be interesting to see how long it takes to upload this. I'm in Italy with a very crappy internet connection, so I might have to always upload this stuff during the night. Maybe I can set up a script so I push the file to my Raspberry Pi and then the Pi uploads it during the night, so I don't have to leave my computer running. I'll have to kind of think what I can come up with. And yeah, so now I'm going to check this and see if the audio is fine, and then upload my first screencast to YouTube, which is really quite personal and not at all educational. Bye.